All right, Chapter 3, Section 2, Factoring Special Products. We've been doing factoring of quadratics, and there are a couple that are special, where they always follow the same pattern. And so if you memorize what these are, it can help you solve a little faster, a little easier. The first one we're going to talk about is factoring the difference of two squares. So this is going to be, you only have a binomial. You only have two parts, the squared part and the constant part, the number part at the back. You've lost that linear term. It's not that it just isn't there, it's that you have zero of it. And since we have zero of it, we don't really have to worry about it. And that's kind of how it goes, and that's how this works. So the difference of two squares pattern looks like this. You're going to have a squared term at the front and a squared term at the back, and we have to be doing a difference, which means we're subtracting. When you do that, what you get is a square root of the first in each, a square root of the last in each. One's plus, one's minus. Always works that way. It also works in the reverse. If you're multiplying these two binomials together, and you notice they're the exact same numbers front and back and different signs in the middle, it's going to turn into square the front one, square the back one, minus in between. Here's an example in numbers. X squared minus 9. 9's a perfect square. So it could be x squared minus 3 squared. So each one gets an x, and each one gets a 3. One's plus, one's minus. Goes just like that. So let's look at A here. X squared minus 25. Well, the square root of 25 is 5. Hopefully we know that one, so we can immediately just throw our parentheses down, put an x in each. We know it's plus and minus because it's a minus at the back. It's a difference. And the square root of 25 is 5. And it factors nice and easy. B gets a little crazier. We got 4z squared minus 1. Well, we'd like to slide and divide, and you could do this, but if you really look at it, 4 is also a square, right? It's 2 squared. So I could rewrite this as 2 squared z squared minus 1. 1 is also a square because it could be 1 squared. 1 times 1 is 1. Which means I could write it as 2z all in one thing squared minus 1 squared. And there's my difference of squares. This thing I have at the front is squared, and this thing I have at the back is being squared. So when I write my parentheses, each one gets a 2z, and each one gets a 1. One's plus, one's minus. And there's my answer. Okay. Now, the book goes into a way of thinking mathematically that would be beneficial if, for some reason, maybe you didn't have a calculator. And you had to evaluate this 54 squared minus 48 squared instead of doing 54 times 54 and 48 times 48 and figuring out what those are and then subtracting them. They teach you to use the difference of squares to kind of help out with that. We're not going to use that much, but I'll show you just in case you ever want to practice it and use it, put it in your mathematical tool belt. So what we do is we've got two squared things and we've got a difference. So we just make our two parentheses and we get 54 plus 48. And we get a 54 minus a 48, a plus 1 and a minus 1. That's what happens with difference of squares. You get a plus it and a minus it. Well, 54 and 48, let's see. See, I'd still almost need a calculator for this, so it's not really helpful in this situation. But 54 and 48. Take 54 and we go up by 8, so that would be 62. Plus 40 makes 102. And my other parenthesis, 54 minus 48, the difference is 2, 3, 4, 5, 6. So now we're stuck with 102 times 6. Well, 102 times 6 still isn't all that easy. I might still need to put that in a calculator. You can separate it. You could say 100 times 6 plus 2 times 6. That's 600 plus 12, so it's 612. But it's not that much easier. When we get to some of these other examples, I'll do a couple of them and show you how those kind of go easier. But for the most part, you're probably going to pull out your phone and just type it in. That'll be the easiest way. Heck, some of you can even just push a button on your phone and ask your phone to do it for you, and it will. So probably not that useful for us. Factor the polynomial, so let's practice some more. So all of these on top, those are difference of squares. So let's look at number 1, okay? Why not pause right now, try 1, 2, 3, and 4, and then I'll tell you how they go. So give it a pause right now and try. All right, here's number 1. X squared minus 36. X squared is a square, 36 is a square. You could do it as 6 squared, 6 times 6. So my parentheses always get 2 with a factoring of a quadratic. I know it's quadratic because I got a squared term. Each one gets an x. One's a plus, one's a minus. Both get a 6. Number 2, 100 minus m squared. Okay, well, they've rearranged them, which is all right. We can still make do with that. We're just going to do the 100 in the first spot and the m in the second spot. So the factors of 100, that's like 10 squared. So each one gets a 10. Each one gets an m. One's plus, one's minus. Number 3, 9n squared minus 16. Well, 16 is 4 squared and 9 is 3 squared. So in my parentheses, there's going to be a 3n in each. There's going to be a 4 in each. One's plus, one's minus, and that's just the pattern and how it goes. The tricky part is you have to know your squares. If you don't know 4 and 9 and 16 and 25 and 36 and 49 and 64 and 81 and 100 and 108 and not 108, 121 and 144 and 169 and going on and on and on and on, then you're not going to recognize these and the pattern's not going to do any good. So then you just slide and divide. But what you're trying to make in the middle, remember what this is, as we get into these, this is like 100 minus 0m minus m squared. We need to rearrange that and factor out the negative. This is like x squared minus 0x minus 36. This is like 9n squared minus 0n minus 16. Or plus. It doesn't matter what way you make the 0. It's neither plus nor minus. But that's what it's doing. You could slide and divide them all. But if you recognize the pattern, it's even faster. So if we look at number 4, 16h squared minus 49. 16 is 4 squared. 49 is 7 squared. So that's 4h, 7 and 7. One's plus, one's minus. Boom, 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 boom. And you're done. Okay. Now, I'll look at a couple of these weird ways to think about, evaluating an expression. They're not my favorite. I don't like them, but sometimes it makes it a little bit easier. If we look at the first one, we get 2 sets of parentheses. There's a 36 in each. There's a 34 in each. One's plus, one's minus. Well, 36 and 34, the 4 plus the 36 makes it 40, plus that makes it 70. And 36 minus 34 is 2. 70 times 2 is 140. That one was pretty easy. The 47 and the 44, that one's going to get weird because you're going to end up with a 1 at the back. Not my favorite. The 55 and the 50, kind of possible. The 28 and 24, also kind of possible, but not my favorite way to do it. You're probably going to type it in a calculator anyway. Okay, so use it if you want. We're going to skip it. The next kind of special pattern. So the first one is difference of squares. 2 squared things, a binomial minus in between. Both have to be a squared type. The other one is a perfect square trinomial. It's all about the squares, though. Tri means 3. It's going to have 3 parts. So we've got perfect square trinomial pattern. If you've got a squared thing plus 2 times the square root of the first and the square root of the last, plus the last thing that's a square, it turns into a plus b squared, or a plus b times a plus b. That's what it means to be squared. This one would be a minus b times a minus b. Notice this time in our 2 parentheses, it's the exact same thing. Plus plus, minus minus. Difference of squares gives you different signs. That plus at the back, you're both going to be plus, you're both going to be minus. So here we have an example over here on this side. X squared plus 6x plus 9. The square root of 9 is 3. The square root of x is x. 3 times x is 3x. And if you double it, 6x. That's what you get in the middle. So this happens to be a perfect square trinomial. So really all you need to do is you're going to throw out your parentheses. Each one gets an x. Each one gets a 3. And then they're both the middle symbol, plus plus. Same thing happens on the bottom. So it's just learning to recognize that's there. The clues are at the front and at the back, and if there's a plus sign. So I've got a squared thing in front. I've got a squared thing in back. 16 is a square. It's called 4 squared. And I have a plus sign. So I'm okay to do a perfect square trinomial and see if it works out. So I'm just going to write it down. Each one gets an n. Each one gets a 4. Both are plus. And is 4 plus 4 positive 8? Yes, it is. So I'm good. I could even write it like this. That's a 2, by the way. Okay. Either one of those answers is good. On B, I'm looking at the back. It's a plus. I've got 3 parts. Okay, is the front a square? Well, yes, this could be 2 squared. And this could be 3 squared. So I write down my parentheses. I'm going to hope that they end up doing the 12. So I'm going to write a 2x and a 2x. I'm going to write a 3 and a 3. Just like we did with the difference of squares. The square root of the first thing in each, the square root of the last thing in each, but this time, matching symbols. Now let's do the FOIL just to make sure. I'll do it in a different color just to show you. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x, which is negative 12x, which is what we needed in the middle. So it was a perfect square trinomial. Okay. It's just seeing that pattern. If you don't see the pattern, then just ask your question. Factors of 9 that add to negative 6. Factors of 16 that add to 8. Factors of 9 that add to negative 12. Well, of course, you had to slide and divide that because it didn't have a greatest common factor, and you have that 4 in front. So just make sure you do that slide and divide. Solving a polynomial equation. So now we're in the solve, and we're in the equation, which means we have an equal sign. There it is. When we solve a polynomial equation, we want to get what we're going to do, what we're looking for. These things graph like a U. A parabola is what it's called. And what we're looking for is where they touch the x-axis. And where that is, these spots, the x-axis, this is the x-axis, it's when y equals 0. So what we've done is we get the equation so that it's y equals everything else over on the other side, and y is all by itself. And then what we do is we plug a 0 in for y, and we want to know what x makes that y is 0 true. So we're going to factor it apart. Okay. We're going to factor this thing apart. Now, they gave us a really toughie because they gave us a fraction. I'll show you how to do it with the fractions, and then I'll show you how to do it without. They're not going to give you one like this that doesn't go really nicely. If you notice, 1 is a square, and 9 is a square. So they gave us a perfect square trinomial. So we should be able to break it into pieces. Each one gets an x. Factors of 1/9 are the squares of the top and the bottom, square roots of the top and the bottom. Square root of the top is 1, square root of the bottom is 3. Square root of the top is 1, square root of the bottom is 3. And then it's plus plus. I know it because it's a trinomial, it's got a plus at the back, and so the middle goes to both. Now here's what you do when you solve it. We use what is called the zero product property. And we're going to get to that eventually. I don't know why they don't cover it right now, but it's the zero product property. The way they do it in the book is they just turn this into this problem, and they go for solve. And with solve, we're going to SADMEP instead of PEMDAS. We're going to look for subtract adds, divide multiplies, exponents in parentheses to get rid of. So outside of everything, do we have, like the parenthesis inside there is going to be the last thing we do. So then we work our way from front to back. No add subtracts to get rid of outside the parenthesis, no multiply divides to get rid of, but there is an exponent. The opposite of square, square root. So we get x plus 1/3 equals square root of 0, 0. Then go through the process again. Are there any subtract adds to get rid of? Well, I've got to add to get rid of, so I subtract it from both sides. So x equals negative 1/3. Technically does it twice because we had 2 parentheses for it. So I'm going to show you a little bit different way to do that over on the other side. We were at x plus 1/3 times x plus 1/3 equals 0. We're going to get into, I think in the next section, something called the zero product property, which says that when things multiply together, if any of those things is a 0, then the whole thing becomes 0. So if we want to equal 0, we either need this one to be 0 or this one to be 0. So what we need to do is figure out what the x needs to be in the first parenthesis to make that a 0, and what the x needs to be in the second parenthesis to make that a 0. So just take each one individually and set it equal to 0. These ones are exact same, so it's going to be the same number, but we subtract the 1/3 from both sides, and we get x equals negative 1/3. If we were to plug that in, if we plug in a negative 1/3, negative 1/3 plus a positive 1/3 turns to 0. 0 times anything, 0. It works. We can plug it back in the original. It works. We can even go to Desmos. That's not what I wanted to do. I actually wanted just to bring it up only slightly. Okay, and we can type in x squared plus 2/3 x. Oop, x needs to go on the side, so move out. Plus 1/9, move out. Nope, just a 1/9. Okay, so then we zoom in, and we got to go, okay, where is it touching? It only touches at one spot, and it's negative 0.333333. You should know that's 1/3 when 3 repeats. So you can do it graphically as well. Okay. So let's look at some examples. Try 9, 10, and 11. Give it a pause right now and try them. All right, let's look at 9. All we have to do is factor it. M squared minus 2m plus 1. That's like a 1 squared. So that's a trinomial. I got a plus at the back. I got a square at the front, a square at the back. It's probably a perfect square trinomial. Each one gets an m. Each one gets a 1. They're both minus. Let's see. Negative 1 plus negative 1 makes negative 2. There's my answer. Let's look at 10. Doing a different color so you can tell the difference. D squared minus 10d plus 25. That could be 5 squared. So I got a square at the front, square at the back. This one's a plus, so they should both be like this. They should both have a minus in them. This one gets a d, that one gets a d. This one gets a 5, that one gets a 5. Negative 5 plus negative 5 makes negative 10. So yes, it was a perfect square trinomial. Let's try 11. 9z squared plus 36z plus 36. So that could be 6 squared. This could be 3 squared. So let's try it. Each one gets a 3z. Each one gets a 6. They're both plus, like the middle. So let's see. 3 times 6 is 18z. 6 times 3 is 18z. 18 plus 18 makes 36z. So yes, it was a perfect square trinomial. Now give 12, 13, and 14 a try. You're solving. Okay? You're solving. You're going to set either one equal to 0. Once you get those factors, set each factor equal to 0 and figure out what x you need to make that one parenthesis a 0. Give it a try right now. All right, let's look at 12. A squared plus 6a plus 9 equals 0. Well, that's 3 squared. So that's a squared. Nope, not the squared. I want more parentheses. That's an a and that's an a. That's a 3, that's a 3. They are both plus. That's what the middle has. So I've got the same thing twice. So a plus 3 equals 0 and a plus 3 equals 0. Minus 3 from both sides. A equals negative 3 and technically negative 3. Does it twice. You only have to list it once, but there you go. Okay. I'm going to erase that one So I have room for 13. 13, look at those frickin' fractions. But let's assume they did something nice for us, right? W squared minus 7/3 W plus 49 over 36 equals 0. Oh my gosh, those are all fractiony. But 49 is 7 squared and 36 is 6 squared. So I'm assuming that each one gets a W. Each one gets a 7 over 6. And they're both minus. Still equals 0. Don't forget to bring down your equals 0 part. Set each one equals 0. It's the same thing, so I'm just going to do it once. Add the 7/6 over. W equals 7/6. Boom. Let's look at 14. 14 will show you two ways. There's algebraically, and then there's factorially. I'm going to do factoring first. 81 could be 9 squared. This is a difference, so that means each parenthesis gets an n, each parenthesis gets a 9, but since it's difference, they got to be different signs. So now I've got two different kinds. I got n plus 9 equals 0, and I got n minus 9 equals 0. Subtract the 9 both sides here, n equals -9. Add 9 here, n equals +9. So we get two answers. N is 9, -9. Okay. Graphically, let's look at that. If I type that one in, of course I'm going to slide this over here. Let's see. X minus 81. Any variable works. X is their favorite. So, and I forgot to square it. So x squared minus 81. Let's go home. Okay. Boom, boom, boom. Where it crosses the x-axis, -9 and +9. And those are the answers I got. Yay. Solving by graphing, kind of easy. Has to be set equal to 0 though, otherwise it doesn't really work. So make sure it's set equal to 0. The other way that they probably would have solved this is they would have done what's called algebraically. It's another way to do it. Yeah, n squared minus 81 equals 0. Well, to get n by itself, SADMAP, add, subtract away. N squared equals 81. Square root both sides. Square root of n is n, because it's n times n. There's my pair up, square up. This is 9. Pair up. But when you square root, don't forget, negative times negative is also positive. So not only is it 9, but it's -9. Sometimes written like this, plus or minus 9, because it could be the plus one, could be the minus one, could be either. That's what they're doing there. Now let's check out word problem. It's going to use what we just did. We're going to either factor a trinomial, perfect square trinomial, or factor a difference of squares, most likely. So let's look. A bird picks up a golf ball and drops it while flying. Look, there's a bird. He dropped a golf ball. It even tells you an equation. The function represents the height, y, in feet of the golf ball t seconds after it's dropped. So y equals 81 minus 16t squared. The ball hits the top of a 32-foot tall pine tree. After how many seconds did the ball hit the tree? Okay, so that ball's falling. Here's my pine tree. It's not really how a pine tree looks, but you know, like that. And it's going, it hits, and this is 32 feet in the air. The equation, y is equal to how high it is in feet. So we want to know, when is it 32 feet high? So this is like my graph, and I'm up here at 32 feet. When's the ball at 32 feet? So they gave me my y. So I'm going to plug that in. 32 equals 81 minus 16 t squared. Okay. Now to solve, I want to solve for t, time, seconds. I have to get it set equal to 0, so move the 32. 0 equals, let's see, 81 minus 32, borrow. 11 makes that 9. 7 minus 3 is 4. Okay. Oh, look at that. That's 7 squared. That's 4 squared. That's a difference. I got difference of squares. 0 equals. There's a 7 in this one, a 7 in that one, a 4t in this one, a 4t in that one. One's plus, one's minus. So set each one equal to 0. 7 plus 4t equals 0. 7 minus 4t equals 0. Move your 7. It's the same step in both equations. That's supposed to be 4t equals -7. Negative 4t equals -7. Get rid of your 4. Get rid of your -4. Okay. So t equals, well, that's just a weird little fraction. It's either -7/4. Let's see. When we divide it by -4, negative makes +7/4. Well, how do we count time? Do we say it took -5 seconds to get there? No, you can't have negative time, so it's not that one. So it has to be t is 7/4. So 1.1 3/4 of a second, or 1.75 seconds. Usually you put your units on there, seconds, right? And that's how long it took. Plug in the y, get it set equal to 0, solve it. Yes, you could rearrange it to -16t squared plus 49, and then you could take your -1 out and get 16t squared minus 49, and then you still have and you got it equal to 0. You could divide your -1, then you have 16t squared minus 49 equals 0, and your t squared's in the front, and you still have a difference of squares. It still works either way, okay? If you want to try that last one, not that. There it is. They just change it up. What if the golf ball does not hit the pine tree? How long does it take to hit the ground? Okay, well, let's draw a picture of it just in case. There's our bird, right? He dropped a golf ball. It's falling. There's our pine tree. Happy little trees. Thank you, Bob Ross. Okay. And we want to know, goes through here, straight past it, and it goes bonk, and it hits the ground. Well, if this was 32 feet high, how high is the ground? Well, the ground's at 0. So if we say 0 equals 81 minus 16t squared, give it a pause. You try to finish it, and then watch me. 9 squared, 4 squared, 0 equals, difference of squares, 9 in each, 4t in each. One's plus, one's minus. 0 equals 9 plus 4t. 0 equals 9 minus 4t. Move the 9. -9 equals 4t. -9 equals -4t. That's supposed to be t. Get rid of your -4. Get rid of your 4 in this one. -9/4 equals t. 9/4 equals t. So what are those equivalent to? Well, 4, that's a negative. 4 goes into 9 2 times with 1/4 left over, also known as -2.25 seconds. That doesn't make sense. It's negative time. Or we've got 2 1/4, which is 2.25 seconds. That one makes sense. That's our t. Okay.